do this scenarios and to do this update for the WEAP model. And now we can say that this model now is like a platform for scenarios development and testing let's say, factors that could impact the resources and our demand in different sectors. So in this presentation, we will have two parts. The first part will be presenting the WEAP concept and the features and the applications done for the Jordan, specifically the countrywide model. The second part will be presented by my colleague Adel Abayat from the ministry, who will present the main, let's say, and more interesting results for the domestic sector, from demand and supply at country level, and of course for some governorates and projects level, like Irbid, Wadi al-Arab, and Samra wastewater treatment plant. The WEAP model, or the software, the WEAP stands for Water Evaluation and Planning. It is a software, has been developed by Stockholm Environment Institution since 25 years. The main features of the WEAP is that reflects the natural processes, the hydrological and the groundwater modeling. On the other hand, it presents the anthropogenic processes, including the demand for each different sectors, the well fields and the dams, the canal systems. And of course, we have the simulation between the demand and the supply from different sources, whether it is surface water or groundwater, into different, let's say, demand sides, irrigation, domestic, or the industrial. The main feature of the WEAP, it is a GIS-based graphical drag and drop interface. It has a number of built-in routines and functions, including the plant growth, the water quality, and financial analysis as well. It has also its own, let's say, the user can put his own user-defined variables. It is a strong scenario management functionality for medium to long-term analysis. It can be coupled with other, let's say, models like the groundwater model flow, the surface water quality model, and socioeconomic models. The application developed in Jordan, the countrywide model, our famous countrywide model, the aim of this countrywide model is to demonstrate the current water systems of the whole country from demand into, from supply into demand schemes. It simulates the water transfer within and between governorates. It is a policy analysis and planning tool that evaluates for a range of various water planning strategies and scenarios. We are testing a different orientations or direction of what-if scenarios from, let's say, the demand or the supply perspective. The components of the countrywide model has the main scheme or the schematic of the WEAP, which includes the 94 demand sites, indicates domestic, agriculture, industry, and tourism sectors. It has 24 well fields nodes. It has more than 240 transmission links and 80 diversions, plus the wastewater treatment plants. We represent the main wastewater treatment plants, 22 within our schematic. How we define the water demands for the domestic sector, there is 3 categories of criteria. For private household, it reflects the district levels, from governorates into district levels. It has reflection on the allocation policy, the population plus the allocation policy, the 120 liters per capita per day. For Amman, 100 for the urban and 80 for rural, based on the allocation policy. For the commercial, we consider small industry and restaurants and shops, which is also supplied within the network, also at district level, which is calculated as percentage of the total domestic demand, since it has the same source from the network. The tourism has another cascade, which is the hotel beds and the occupation and stuff like that. For the demand for refugees, there is 2 nodes or 2 different settlements. Overall, we have 150 million people estimated by end of 2015, and they have their own, let's say, growth. The nodes or the modes of settlements, whether we have the refugees within the camps or the refugees in the host communities. For the camps, we have 5 known camps with total capacity of 115 people. For the water provided for these people within the camps, it's estimated at 30 or allocated like 35 milliliter per capita per day, as per the policies and the UN data. The refugees sitting within the host communities, they have the regular, like the regular population within the host communities, who is supplied like the allocation policy, the 120, whether they are in Amman or 100 within the urban places or the rural places. And as we all know, most refugees settle in the urban centers within the North Governorates of Jordan. For the industrial water demand, top water consuming industry would have fixed amount of water, like the potash or the oil shale. They have their own, let's say, wells, or they have their own sources, so they have fixed amount, and we consider the growth on this as per the demand increase and the estimated demand. All the other industry are covered within the commercial demand. The agriculture water demand, they have also their own, or say, specific treatment. The special resolution, the governorates, we split also within the model, the JV from the highlands as per the demand and the sources. Determinant factors for the demand is the crop area, and we have used recently the remote sensing technology to estimate the water demand, and also the JVA data. The crop water demand as per the FAO and JVA, Ministry of Irrigation data. The irrigation efficiency is also one important element or parameters that embedded within the agriculture demand estimation. From the water supply point of view, we have the different sources, mainly groundwater, surface water, and the treatment wastewater. The desalination also, the foreseen, the coming or foreseen important resource recently. For the wastewater treatment plants, we have 22 treatment plants. The key figures for these treatment plants are the daily capacity, the inflow and the outflow from the treatment plants, the loss within the treatment processes or facilities, and it is important to have the percentage of households connected to this wastewater treatment plant to estimate also the inflow expected to be received by these treatments. Some wastewater treatment plants, as we know or discussed before, that use the outflow for the irrigation purposes. For the well field and pipelines, the known abstraction and transfer volume are used. So these data are collected from the WAJ according to the yearly supply. The following physical parameters are used also: the pipe parameters, the capacity, the velocity within the flow of the pipe, the maximum pipe flow, and variation of flow over the time. The non-revenue water is also is a main parameter within the model, where it is divided into physical and administrative losses. The physical losses, the water lost in the transmission between the bulk water supply into the meter, which is assumed that it's 50% of the non-revenue water, as per also the National Water Strategy and the allocation policy. The administrative losses, it is the water not billed, but consumed by the consumers. This is due maybe the no meter or free of charge or illegal connections. I will leave this part for Adel.
Thank you, Hala, and thank you all for attending this session, and thank you, Your Excellency. I will move forward with this presentation by showing some of the results of countrywide model, or the WEAP model. We have in WEAP models, we examine different scenarios, but the main ones are the reference scenario. The reference scenario is showing the current situation until the year 2017 with the demographic growth according to the population in the last census, and it also models the projects under implementation, like the project of Wadi al-Arab Conveyance. We have also the new resources scenario, which is, the main elements of this scenario is the major projects according to the capital investment plan, including the desalination projects and the Wadi al-Arab phase 2 projects. It has also, we modeled the expansions in the wastewater treatment plants, increasing the connection rates in the urban areas, and also the non-revenue water reduction plan as in the water reallocation policy. So before I show the results, I want to explain some definitions which is important for understanding the results of WEAV models. The domestic water demand is the amount of water required at demand sized according to the reallocation policy. And the supply requirement is the water demand, but we add to this demand the physical losses. Because if I want to deliver, for example, 500 million cubic meter or 100 million cubic meter, I should consider the physical losses into account. So the third definition is the supply delivered, which is the amount of water supplied or pumped to demand sites, which is restricted by the predefined supply requirement, which I explained earlier. Going to the results, we have the reference scenario results. It shows in the lemon color the water demand, which depends only on the population of the demand sites. So the demand is increasing because population is increasing. And in orange, we have the supply requirement, which is the demand plus the physical losses. And it's also increasing because population is increasing also, with no reduction plans for non-revenue water. The third is the supply delivered. There is always a deficit between the supply delivered and the supply requirement, which is reflected in the gray or blue bar. It's showing the deficit in the water supply. So the deficit is increasing because resources are not developing in the reference scenario. This is the results of the new resources scenario without non-revenue water reductions. We can see that the demand the same, like the reference scenario, and the supply requirements are the same, but the supply delivered is increasing comparing to the reference scenario because we are developing in the water sector new water supply projects. So in the year 2029, there is no change in the supply requirement. Increase in supply delivered is 30% of the original supply, which is around 153 million cubic meter, and there is a reduction in the unmet demand by 55%, which is